Hello everyone, I am Helena Lina Susilawati from Indonesian Agricultural Environment Research Institute. My talk is about Integrated Crop-Livestock Management System in Rainfed Lowland. The outline of my presentation is introduction, materials and methods, results and discussion, and the last one is conclusions. The background of my study because the world faces a major food security challenges due to the climate change impact on overpopulation. Rice cultivation is one of the main sources of global greenhouse gases emissions, including methane and nitrous oxide. Flooded rice fields is one of methane contributors because flooding of rice fields cut off oxygen supply from the atmosphere to the soil, which leads to anaerobic condition as potential condition of methane production. Fertilizer help farmers grow more food on less land and feed the growing population. However, end use efficiency is quite low because of the rapid loss of end fertilization. Ineffective use of end fertilization contributes to nitrous oxide and methane production in the soil that cause global warming. But agriculture can help mitigate climate change by either reducing greenhouse gas emission or by sequestering carbon dioxide from the atmosphere to the soil. In the rainfed rice ecosystem, the amount and timing of water supply and soil fertility are considered to be the most severe constraint to the productivity. However, agriculture needs to meet the food, fuel, and fiber demands of the growing population while protecting environmental quality and providing adequate financial return to the farmers. Thus, emerging agriculture concept is needed to address this demand, include improvement in sustainability and the implementation of ecologically correct techniques. The concept is integrated crop and livestock system because it provides an alternative to increase animal and crop production, stimulate and improve land quality through efficient use of natural resources. The objective of my study is to investigate the greenhouse gas emission, rice production, and economic efficiency of integrated crop livestock management system in small-scale farmers. The study was conducted at 3 sites in Pati, Central Java, Indonesia. The farmers who are selected based on the ownership of rice fields and cattle. The experiment was laid out in the randomized block design and comprised of farmer practice as a control and integrated crop livestock system with 3 applications. We combined the approaches of the cultivation management into one technology package. We combined the age of the seedling, planting size, water management, fertilization, and pest disease management. We chose the approaches that can mitigate and adapt to the climate change, such as intermittent irrigation, site-specific nutrient management, etc. Intermittent irrigation not only can reduce methane emission from paddy soil, but also save water from the field. The methane and nitrous oxide fluxes were measured by closed chamber method and collected by 10 mm of shearing. 4 hills of rice plants were covered by methane chamber with measure 50 cm times 50 cm times 100 cm. Each experimental plot also had chamber for collection of nitrous oxide with measured 40 cm times 20 cm times 30 cm, and no rice plant were covered. The concentration of methane and nitrous oxide were directly analyzed with a gas chromatograph, which was equipped with a flame ionization detector and an electron capture detector from methane and nitrous oxide analysis. We can see from the figure that viewed from integrated crop livestock system plots were around 2.2 until 27.7% higher than yield from farmer practice. This is probably because of the application of site nutrient management. There was a tendency of GHG emission reduction, approximately around 23 until 32% due to the integrated crop livestock application. The most dominant factor that influences GHG emission is water management. Water management changed the soil water content, and it made aerobic and anaerobic conditions. Drying water from soil gives effect to the higher redox potential, and it could decrease the amount of methane emission. However, water saving should manage fields adequately supplied with water for the roots of rice plants to maintain rice yield. Greenhouse gas intensity is the comparison between greenhouse gas emission and yield. The lower value of the GHGI after treatment gives more benefit. We can see from this figure that GHGI from integrated crop livestock system plots were lower than from farmer practice plots. This finding indicates that integrated crop livestock system approaches in a rice field could be used to reach greenhouse gas reduction and yield gain. We also investigated greenhouse gas emission that released from manure. It calculated from methane emission from manure, direct and indirect N2O emission. Manure management without anaerobic digester released GHG emission, while using anaerobic digester could avoid GHG emission to the atmosphere, and the biogas that produced from the digester could be used to substitute LPG and kerosene. We can see from the table of chemical characteristics of the soil. C organic and CEC from integrated crop livestock system plots were higher than farmer practice plots. Some studies say that there are correlation between CEC and percent organic matter. The return of rice cultivation practice from non-integrated crop livestock system plots were around 9.7 until 12.5 million rupiah, and from integrated crop livestock plots were around 9.2 until 15.3 million rupiah per hectare. Benefit cost ratio of the rice cultivation practice from non-integrated crop livestock system was 0.74, and from integrated crop livestock system was around 0.75. It means that integrated crop livestock system give more profit to the farmers. From this study, we can conclude that integrated crop livestock system reduce greenhouse gas emission from paddy field. Integrated crop livestock system avoided methane release from manure of livestock using anaerobic digester to the atmosphere, and used the methane production for energy purposes. Integrated crop livestock system improved the soil fertility by giving additional composted farmyard manure to the soil. And the last one, integrated crop livestock system enhanced the economic benefit for farmers. So, integrated crop livestock system approach is one of the options where adaptation and mitigation technology could be conducted in a synergetic way. This is the end of my presentation. Thank you.